Synchronous motion. Under synchronous motion, the topic which I've chosen is testing of synchronous motion. So let us move on to the testing of synchronous motion. Under the testing, there are various methods of testing, such as testing the insulation resistance, testing the DC resistance, measuring the DC resistance of both the armature and the field windings, testing dielectric of the stator windings by applying AC voltage for a minute. We also do dielectric test with DC voltage. We perform DC resistance test for measuring the field discharge resistor. We also perform testing of insulation of the field discharge resistor with respect to the frame, testing of insulation resistance and dielectric withstand of the field insulation. We measure the vibrations, noise. We measure the air gap between the stator and rotor, open circuit and short circuit characteristics, sudden three-phase circuit test, and testing the voltage regulator excitation system. Especially for motors, we perform DC resistance measurement, dielectric measurement, mechanical balance measurement, current balancing measurement, phase sequence test, overspeed test, harmonic analysis test, telephone interference test, reactance and time constants, bearing insulation test. Let us see the first test, which is called voltmeter ammeter method. In this test, ammeter is connected in series to the supply and voltmeter is connected in parallel to the supply as well as to the load, in which the voltage which is applied across the winding and current which is connected in series are noted at a specified temperature. After noting down both voltage and current, you take the ratio of voltage and current, which gives you the resistance. And this test is suitably done for field winding resistance, and you use Wheatstone's bridge or Kelvin's double bridge to measure the high and low voltage. Especially field winding, you use Wheatstone's bridge, and for armature winding, you use Kelvin's double bridge. And as the resistance are very sensitive to temperature, the temperatures are also recorded and 3 to 5 readings are noted down. Next, let us see what is DC resistance of the winding. How do you measure it? The DC resistance are measured at standstill condition by allowing the rotor to be exposed for a sufficient period of time. Then you apply some temperature. At ambient temperature, you are going to make the synchronous machine to rotate. The reference resistance helps in determining the field temperature, and when the reference resistance is measured, the current circulation through the field coil shall be very low, so both the resistance and the temperature can be determined more accurately by conducting the test when the generator is running under normal speed. Next test is open circuit test. This test is also called as no load saturation test, in which the windings are kept open and you apply the DC voltage to the field winding resistance. The curve which is shown over here is the open circuit curve, which gives you the relationship between the armature terminal voltage and the field excitation current. The prime mover is made to run at rated speed. The excitation is varied in steps and no load voltage is recorded here. During the no load losses of the machine can be obtained. Let us see what is sustained three-phase short circuit test. In this test, you are going to short circuit the windings in such a way that ammeters are connected in series with them. In this particular test, the synchronous generator terminals are shorted through ammeters and the field current is increased till the armature current reaches a maximum value. Once it reaches a maximum value, the relationship between the field current and the short circuit current are drawn, and this characteristic is called short circuit characteristics. In sustained short circuit test, the values of the field current and the armature current are always referred to the steady state values, And the sustained three-phase short circuit test is conducted by a retardation test onto the machine. So you would have studied retardation test in the 4th semester. So here the motor is driven at rated speed and excited at short circuit current in the armature. The machine under the test is retarded by putting off the supply to the drying machine. The armature current in each phase and the corresponding field currents are noted down. If the machine has retarded above 4% of its rated speed, then the excitation is taken. Coming to the next test is the short circuit ratio test. In this test, you are going to perform the short circuit ratio, which is defined as the ratio of the field current during open circuit to the field current during short circuit, and this is done when it is maintained at rated speed. The impedance in the steady state condition is measured at synchronous impedance. Well, how do you define short circuit ratio? It is defined as the ratio of field current at the rated armature current on sustained symmetrical short circuit to the field current at normal open circuit on the air gap line. The last test is called sudden three-phase short circuit test. In this test, you are going to short circuit the windings in such a way and connect it to the CRO. The sudden three-phase short circuit test is usually conducted at rated speed at desired no voltage value. The three phases are shorted suddenly. The terminal voltages of the machine and the excitation current are measured just before you're short circuiting it. Coming to the next test is the negative phase sequence test, where in this test this is the equipment which you're using, and this is used when the symmetrical voltage is applied to the machine at rated speed and it is connected to the external source with negative phase sequence. What is negative phase sequence? Which is operated when you break with the slip when it is equal to 2. The excitation windings are short circuited, and if the residual voltage is exceeding 0.3 times the supply voltage, the rotor should be demagnetized before testing the machine. Next test is the temperature rise test. Temperature rise is used to measure the temperature at different parts when the motor is running. There are three methods of measuring the temperature rise. One is called the embedded temperature detector method. Second method is called resistance method. And the last method is called thermometer method. So let us see what is embedded temperature detector method. In this method, you are going to detect the temperature by using resistance thermometer, which is present inside the machine, which are inaccessible when the machine is assembled. This method is usually used for the stator windings. 6 detectors are used in the machine around the circumference. Coming to the next method is the resistance method, where you use the temperatures are determined when it is directly proportional to the resistance of the winding. The last method is called thermometer method, where thermometers are placed at the surface of the machine. What are the abnormal conditions which you find in the machines? Some of the abnormalities or faults that are occurring are the abnormalities. Whenever a fault occurs with large short circuit current, severe mechanical stresses will be imposed onto the stator windings. If there are any mechanical defects which are already existing in the windings, they may get aggravated too much, and temperature rise will also affect, and dangerous temperature levels may be obtained at about 10 seconds. When we talk about asymmetrical faults, vibrations can occur, overheating can occur, and it may cause damages. There are certain abnormal conditions such as thermal overloading, where you due to the increase in the winding temperature, it increases to such an extent that the insulation gets damaged and the life get reduced. Temperature rise can also be a cause for the failure of the cooling system. We have unbalanced loading, where due to the unbalanced load, it causes dangerous heating of the rotor in turbo generators. We also have stator winding faults. Some of the faults are phase to earth fault, phase to phase fault, field winding faults, over voltage surges, loss of excitation, overfluxing, all these faults. Thank you for watching this video. Thank you.